I'm going to talk about prisms. I'll assume that you know what polyhedra are. I'll also assume that you know what I mean when I talk about volumes and areas. If any of that is unclear, then I would invite you to watch the necessary videos. Now let me define what prisms are. Prisms are polyhedra with two parallel and congruent faces, referred to as bases. Okay, so prisms are polyhedra with two parallel and congruent faces, and we refer to those parallel and congruent faces as the bases of prisms. So let me draw an example of a prism. This is going to be a prism with triangular bases. Okay, let me now draw an example of a prism with square bases. Okay. Now, in the two examples that I've drawn, the top base is directly above the bottom base. The vertices of the top base are directly above the corresponding vertices of the bottom base. Now, that is not a requirement to be a prism. So, here's an example where the top base is not lined up vertically with the bottom base. Okay, so that's still a prism. It still meets the requirements to be a prism. Now, let me define a subset of the prisms that meet additional criteria. So if the two bases are lined up vertically, okay, if the corresponding vertices are one's directly above the other one and one's directly below the other one, okay, then you will have faces that are perpendicular to the bases, okay? Those are referred to as right prisms. So the triangular prism, the first triangular prism, the two bases are lined up vertically. The other faces are perpendicular to the bases. So that is a right prism. Okay? And same thing with the second example. The other faces are perpendicular to the bases, the square bases, and the square bases are lined up vertically, so that is also a right prism. Okay? Now, if a prism has bases that are parallelograms, then it is also referred to as a parallelepiped. Okay? So let me draw an example of a parallelepiped. So a parallelogram and then another base that is a parallelogram congruent and parallel to the first one. And again, it doesn't have to be directly above. It doesn't have to be lined up. Both bases don't have to be lined up vertically. Okay? So there's an example of a parallelepiped. Now, if the parallelogram bases are lined up vertically such that the other faces are perpendicular to those bases, then those are referred to as rectangular parallelepipeds. So the second prism from the left, the right prism, is also a rectangular parallelepiped. All right? Now I'd like to talk about volume and surface area with respect to prisms. So let me draw an example of a prism. Give me a minute to finish the drawing. Now, the area of the base is the number of standard-sized cubes that it would take to make one layer that completely covered the base. All right? The distance between the bases is how many of those layers I would need to completely take up the entire volume of the prism. Okay? So all of that is to say that the volume of a prism is the product of the area of a base times the distance between the bases. All right? So the volume of a prism is the product of the area of a base and the distance between the bases. Now, what about the surface area? So, the surface area of a prism is the sum of the areas of all the faces. All right? So let me now do an example where I calculate the volume and surface area of a prism. So once again, give me a moment to make a picture. Let's say that I had a prism composed of bases that were right triangles, and let's say that 2 dimensions of the bases of the right triangles were 3 meters and 4 meters. We'll set the lengths of the legs of the right triangle to be 3 and 4 meters. And so let's also set the distance between the bases to be 10 meters. All right, so can we calculate the volume of that prism? So the area of a base is the area of a triangle, which is 1/2, in this case, 1/2 times 3 times 4. And we're going to multiply that by the distance between the bases, so 10. And now we just have to simplify that calculation. So that's equal to 60 cubic meters. Okay? Now for the surface area, we're going to add the areas of all the faces. So the areas of the bases are each 1/2 times 3 times 4. And we have 2 of those, so I'll multiply by 2. And now I will add the areas of the faces, the other faces that aren't triangles. So I have 3 rectangles. The area of one of those rectangles is 3 times 10. The area of another rectangle is 4 times 10. And to find the area of the third rectangle, I need to know the area of the hypotenuse of the right triangle. I can find that using the Pythagorean theorem. And if you do, you will see that that has a length of 5 meters. So the last rectangle has an area of 5 times 10. All right? So now let's simplify that expression. So the first expression, the 1/2 and the 2 cancel. So I just have 12 plus 30 plus 40 plus 50. And let's see, that gives 132 square meters. All right? Now, I would like you to do a similar example. So, let me draw a prism. So for this prism, the dimensions are 2 centimeters, 3 centimeters, and 6 centimeters. Okay? So find the volume and the surface area of that prism. Pause the video and do that now if you like. Okay, so I'll go ahead and do that as well. So the volume is the product of the 3 dimensions. The base has an area of 18, 3 times 6, and I multiply that by 2. So that gives 36 cubic centimeters for the volume. Okay, and then for the surface area, we need to add rectangle areas together. So 3 times 6, and there's 2 rectangles with that area, plus 3 times 2, and there's 2 rectangles with that area, plus 6 times 2, and there's 2 rectangles with that area, because we have a total of 6 faces. So simplifying that expression, I get, let's see, 36 plus 12 plus 24, which is 72 square centimeters. All right?